All right, when we're looking at compound probability, compound events, you combine two or more events using the word and or the word or. We've already done some of this. There's one part that's a little bit new, but we've done some of this already, so that part should be easy. Or, we already know what happens when we have an or statement. We add them up. We won't add those two things up. And means multiply. We'll get to that in a little while. Mutually exclusive and overlapping, that's what we really need to understand. Whether what we're talking about is a mutually exclusive event or overlapping events. If it's mutually exclusive, it cannot happen at the same time. For example, if I'm doing the deck of cards and I said, what's the probability of me getting a queen or a king? Can I pick one card and get a queen and a king at the same time? No. So those two things cannot happen at the same time. Therefore, mutually exclusive. Overlapping has at least one common outcome. So if I was doing the dice, where we rolled the two dice and added them up, if I said, what's the probability of getting 10 or a number bigger than 7? Can those two things happen at the same time? A 10 or a number bigger than 7? Yeah, because 10 is bigger than 7. So I could roll a 8 or 10 or 9 or anything. It could happen twice. Does that make sense? Mutually exclusive cannot happen at the same time. Overlapping, they can happen at least one time the same way. All right, what all of this means right here is this. If I've got mutually exclusive events, that means it can't happen at the same time. All I've got to do is find the probability of the first one, find the probability of the second one, add the two things up. This Venn diagram at the bottom shows what mutually exclusive looks like. Whatever happens over here can never happen over here. So whatever happens in A cannot happen in B. Like the card deal. If I'm going to say pick a queen, well, queens would be over here. Kings would be over here. Can I pick a king and a queen at the same time? No, therefore they don't overlap. Therefore they're mutually exclusive. All right? Get these right here. You should be able to do them already. All right, if I want to do this right here and say probability of a girl's favorite subject is math or science based on the numbers they gave me down here. So probability of math would be what? 0.25. Plus the probability of science would be what? So then I add those two things up and got my answer. So if it's mutually exclusive, it's the same stuff we've been doing before. Find the first probability, find the second probability, add them up. Find the probability that a girl's favorite subject is not English. Well, so then if it's not English, that means it is everything else. So I would say probability of math, 0.25, plus the probability of social studies is 0.20. Probability of science would be 0.20, and then the probability of history would be 0.25. I would add all those up to get 0.90. Are there questions on that right there? All right. This one should look more familiar. Find the probability of picking an ace or a queen. What's the probability of picking an ace out of the deck? 4 out of 52. Plus probability of picking a queen, because I can't pick a queen and an ace at the same time. But that's also 4 out of 52, so the total would be, now when we did it the first time, we just went ahead and found them and added them up looking at the chart. But this is what we did. And then we simplified it down from there. All right, now you may have to go back and look at that chart we did before. After rolling two dice, what is the probability of getting a sum of a 7 or an 8? How many 7s were in that chart? 6. So the probability of a 7 would be 6 over 36, plus the probability of an 8 was 5 over 36, so the total was 11 over 36. So if they are mutually exclusive and cannot happen at the same time, you find the first one, find the second one, add them up, you got your answer. If we're looking at overlapping events, that's when it can happen at the same time. For example, the one we just talked about a minute ago, where if I pick 7 out of the deck of cards or a red card. Well, I can pick a 7 by itself, right? I can pick a red card by itself, right? Or I can pick a red 7. When it overlaps, this is the formula. You're going to start by saying the probability of A plus the probability of B, which is what we've done before. But then we're going to subtract off what happens, probability of A and B at the same time. The Venn diagram down here is showing what happens when you have overlapping. That stuff in the middle is the overlapping. And we would be counting extra times if we counted everything and didn't subtract off that overlapping part. It'll hopefully make sense when we look at it. Alright, so some examples of overlapping. If you have red cards 1 through 4 and blue cards 1 through 5, find the probability of picking a red card or a 3. Why is that overlapping?
Because you can get a 3 and a red card.
There you go. I can get a red by itself, I can get a 3 by itself, or I can get a red 3. Alright? Probability of picking a card less than 3 or a blue. Well, I can pick a card less than 3, right? Or I can pick a blue card, right? Or I can pick a blue card that is less than 3. So when you have the things that overlap, that makes it an overlapping event versus the mutually exclusive. Roll 2 dice. Probability of getting a 6 or a number less than 10. Well, I can get a 6, right? Or I can get a number less than 10, right? Or if I roll a 6, what is that? It's less than 10. All right. Probability of getting an odd number or a number greater than 8. Well, I can get an odd number like 1, 3, 5, 7. Or I can get odd numbers like 9 and 11 that are greater than 8. So when it overlaps, you need to be able to understand that. All right? Are we good on that? If I'm looking at the first one, it says I'm drawing from a deck of cards. Picking a king or a queen. Mutually exclusive or overlapping? That's mutually exclusive. I can't pick a king and a queen at the same time. Picking a 7 or a club. That's overlapping. Because I can pick a 7, I can pick a club, I can pick a club that's a 7. Picking a face card or less than 5. I can't pick a face card and something that's less than 5. So that's mutually exclusive.
What about an ace? Never mind,
it's not a face card. All right, picking a red or a 10. That's overlapping. Because I can pick a red card or a 10 or a red 10. All right, if I'm using students in high school, picking a freshman or a girl. That's overlapping. So I can pick a freshman, I can pick a girl, or I can pick a freshman that is a girl. Picking a junior or a senior. Well, that's mutually exclusive because I can't pick a junior and a senior at the same time. Picking a girl or a boy. Mutually exclusive, can't pick both. A football player or a senior. That will be overlapping. All right. Any questions on that? If I'm using the chart down here, king or a club, is that mutually exclusive or overlapping? King or a club?
No, it's overlapping.
That's overlapping because I can do a king, a club, or a king and a club at the same time. So first thing I'm going to find is the king by itself. So this is what it's going to look like. Probability of king plus the probability of a club minus the probability of king and club. All right, so if I want to find the probability of a king, what's the probability of king down here?
4 out of 52.
4 out of 52. Plus the probability of a club. How many clubs are there?
13.
Out of 52. Minus the probability of a king and a club at the same time. So how many are kings and clubs at the same time? Just the one.
That's what the answer is going to be.
So then I would say 4 plus 13 minus 1 would be 16 over 52. Simplify that down and get 4 over 13. All right, so for the second one, I'm going to say the probability of number less than 5 plus probability of a diamond minus the probability of less than 5 and diamonds.
Oh, Lord.
All right, so if I look at probability of less than 5, what is that? 'Cause if I do the less than 5, I cut it off here, and I got 16 cards. All right? Plus the probability of a diamond. Well, how many diamonds do I have?
13 out of.
Count the diamonds, there's 13 out of 52. Minus those that are less than 5 and diamonds at the same time.
4 out of 50.
So if I go to the diamonds and say less than 5 and diamond, it leaves ace through 4. So it would be that. So then I would say 16 plus 13 minus 4 gives me 25 over 52. That doesn't simplify. So I've got my answer.